Hey everyone, today I have a flight controller which was sent to me by a company LongFly.co. This company mainly works on manufacturing flight controllers based off the Teensy board. So the Teensy runs the code from the Arduino IDE. It's a pretty fast processor with 600 megahertz clock. So what this company generally does is it develops a flight controller board just like the ESP32 flight controller that I've made, but they have more advanced features. They have put the MPU 6050 chip on here, and they have put a rectifier here, and this just reduces your hassle by a big time. So this is what many of the project DIY project looks like. So this is my ESP32 flight controller. You can see that there's a lot of room for error. Something can go wrong, and yes, I initially had to deal with a lot of burned components. I think I burned MPU 6050s quite a lot, and also I think I burned one ESP32. So to solve all these problems, they have sort of made this. So this comes in with inbuilt rectifier and an inbuilt MPU 650, so you don't have to worry about any hassle. You can just put the Teensy on and get it working. So this is very interesting stuff. This is a very interesting flight controller, and it's a very compact in size. They have been running the Nicholas RAM flight controller code, which is just a code on Arduino IDE. You can just upload it on this code, and that just works. So Nicholas Ram, those of you who don't know, he's an aerospace engineer who who also has a YouTube channel where he puts DIY stuff. And in that DIY stuff, these are very interesting projects where he uses computer vision in order to make drone concepts, and he explains them in a very simple manner. I would, if you're into robotics and you want to dwell in deep, I would heavily suggest you to follow Nicholas Ram. I'll leave all the links in description. So the purpose of this today's video is sort of getting started on this flight controller. Let's just see how it works on our DJI F450 frame and how it just performs. So let's just do that. Alright. Here I have my F450 drone frame. It consists of these DJI 920 kV motors, and it's a pretty simple setup with a LiPo battery, an FSI 6 PWM receiver, a LiPo battery, and PSCs which are connected to the motor. So it is a pretty standard setup. And now we are going to put this Teensy flight controller onto this drone. So before we begin with the hardware connection, let's just take the repository. So I'm going to clone this repository in my system, and okay, so the repository is done. So this is what it consists of. Inside the versions we have these versions, so we're gonna open the latest one. So yep, so this is the flight controller code from Nicholas Ram. So you can see that we have undefined, means we have uncommented MPU 6050 via I2C, and then in the loop section, yeah, so we have to uncomment the print gyro data part. Okay, so we're gonna let's uncomment these two things. So these are the things that we're gonna print out, and let's just upload it on our Teensy. So before we do that, let me unbox it. So this is what you get: a flight controller with the Teensy on board, and here we have a micro USB cable. So that's pretty neat, and a bunch of connectors along with a X360 connector, female version, and we have a bunch of nut bolts to put it all together. So let's just connect the Teensy to our PC. So it's a pretty neat cable, and this is the head of the flight controller. You can see the arrow. So this sort of is forward pitch, and this is backward pitch. So how you're gonna place you're gonna place this on your drone with this as the head. So let me connect it to the PC. Okay, so it's got a pretty good light here, and the Teensy is blinking. So let me just upload it. So before we upload the code on the Teensy, we need to configure the Arduino IDE so that it can upload code in the Teensy. So there's a bunch of steps which are quite small. You have to copy this link. I'll mention this link in the description, and you have to go to your file, then preferences, and you have to add these as well, separate by a comma, and add them, and then okay. So now that we have added it, we have to go to this library manager, is a board manager, and then we have to search for Teensy for Arduino. So yep, so once you get this package, you have to install it. So it's gonna take a bunch of seconds. I'm done with the installation of the Teensy board, and now I need to put this code onto my Teensy flight controller by LongFly. So this is the Nicholas RAM code that we opened earlier. I'm just gonna upload it. Okay, so it calls me for this library is not there. So let's just include this library. It's called PWM servo. Okay, yep. So let's install it. Yeah, so it has been installed. Let's upload again. I think I have to look at the RX communication. Okay, so these are okay. So that error was because of the Teensy board not being selected. So let's upload now. Okay, so these are a bunch of more errors. Okay, yep, I think that's happening. Wait, I have some. Alright. So I use a Linux system, and this was the error that it was showing me. So to combat that, I had to go on this website, and I'd sort of make a file, make a new file in the mentioned directory, and I uploaded that file in the folder, and this sort of solved the problem. This might not be a problem for Windows systems, so worry not. If you are using Linux, this could be one problem which you could solve just by following these guidelines here. And now we're going to upload the code by Nicholas RAM. So let's compile the code. There are some warnings, but let's upload it. So the code has been uploaded. We have to see something in the serial monitor. Yeah, okay, yep. So we have not connected the MPU 6050, so let us connect it to the breakout board and see what happens. So we'll check the arrow and place the Teensy as per that arrow. Oops, yes, so this is right. Okay, and now let's upload the code, see what happens. Okay, so these are the gyro readings. As you can see, the gyro rates are getting printed, so it's pretty easy to start up with that. So let's just put this on the quadcopter. Let's test some motor commands, and let's just go with it. So initially, let's just fix the Teensy's head. So it's gonna be somewhere here, and this is our receiver. So you have to connect some pins from here to the pins on the Teensy. So these are the PWM pins. These are your motor 1, 2, 3, 4 pins. Okay, so let's do that, and I think with that we're gonna get started with that. And now I'm gonna put the LongFly Teensy FC on this. So the USB port is sort of the head of the flight controller. So Red is my head right now, so I'm gonna place it somewhere here. I'm gonna connect the 3S supply voltage directly onto the plus and minus of the Teensy that I get from the battery, and then I'm gonna use some cables to connect the receiver connection to the Teensy's PWM receiver connection, and that's about it. And for the motors, I just have to plug these pins on. So let me do that very quickly in front of you. Let's just disconnect our connection, earlier rectifier connection. So So that's pretty neat, I would say. Not the best, but would do the job. Okay, so more about the PWM connection is that to connect this wire to each channel. So let me start with the red. So I'm gonna connect each channel starting from so the red one goes to channel 1, this goes to channel 2, okay, so that's pretty much done. I could have used these cables to do the job, but since the distance is far away, I use separate wires. So red is channel 1, brown channel 2, yes, black, and then customer. Yeah, so this is pretty much done. Let's connect the motors. So the first is our motor number 1. So motor number 1 we are connecting like this with the signal. I hope this is right. So the 5 volt is right here, as you could see, and the 5 volt is also right here. So I finally configured the code of the Teensy, and I'm able to control one motor. I'm going to show this demo. I had to make a few changes because I have to comment out the one-shot protocol and use the servo motor pins in order to do the controlling of the ESCs. For some reason, these Simong 30 amp ESCs are not getting configured with the one-shot protocol in the Teensy flight controller code, but nevertheless the servoPWM code is getting configured. So I'm going to show you a small demo with this connection. So right now I've connected the Teensy. You can see that one motor beeped. So let me turn on my receiver here. So if you have to just give a jerk to like sort of make it active, and you can see that as I increase the throttle, the motor is going proper direction. So let me just, yeah, it is in the anti-clockwise direction. As you can see, I've connected all the 4 motors onto the Teensy. So now let's just increase the throttle from our receiver and see what's up. So there are the 4 motors. Here I'm increasing the throttle. So you can see all 4 motors have started. You can see there's a slight delay in one. Yeah. So so one of the motors is definitely out of tune, so we have to calibrate all these 4 motors, but that's good. That's a good news. Let me check the PID on this. So now if I move some changes, behind motor should stop. Okay, let me try it with some lower speed. Yeah, so that's working pretty well. I had to just calibrate the ESCs and we're gonna get a decent result. So yeah, okay, so I think I need a good calibration of the ESCs. So that's how you can set up this flight controller and do the calibration. So the thing about the ESC calibration I'm going to do in the next video, where I'm going to also do the PID tuning in order to fly it properly. This video was more like a setup to get everything started on a DJI 450 frame with very basic cheap motor and ESCs and even a cheap receiver. So everything else is set. If you want to get more out of this flight controller, you should definitely check out videos from Drehm. He has used tremendously amazing concepts of computer vision onto drone using the same flight controller board. He is using a Raspberry onboard companion computer to do the AI computing, and that is able to send commands to this Teensy in order to do some object tracking or follow a path. So you can check that out. If you want to get this flight controller, I'll leave a link in the description. You can definitely check that product out. This is a pretty neat product by now, and the code is freely available by Drehm. So there are not much complications in the code. You just have to set it up. The changes that I've done for this code, I'm going to leave it in the description. Make sure to check that out. Other than that, stay tuned for the next video, and always have a good day.